Scientific notation, not really part of what we have to do, but you're all involved in science, and I see some mistakes often made, and it's in this section of what we're doing because the exponent rules that we're dealing with apply. So let's talk about some common mistakes. If I have 328 million, and I want to put that in scientific notation, the big mistake I see people make, one of them is this number that we're going to times by 10 to some power, they don't write that part right. What has to be true about that number is it has to be between 1 and 10. It can't be 10, or we'd have one more power of 10. It can be equal to 1, but it can't be equal to 10. So we know it's going to be 3.28 because that's the only place I can put that decimal and have it be between 1 and 10. So now I have to figure out how many times does that decimal move, because the decimal's right there now. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 10 to the 8th. It has nothing to do with how many zeros, because it depends how many numerals are after the decimal place there. So that would be that number represented as in scientific notation. So that's a really, really big number. Really, really small numbers are also written in scientific notation a lot. So there's a really, really small number. And so if I want to write that in scientific notation, I know it's going to be 4.7 times 10 to the something. And so I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7 times. So this time I went in the opposite direction. I know it's a really, really small number, and now I can tie that exponent rules of small numbers. Okay, so what we're really going to be talking about here today is how would I do a problem like 3.28 times 10 to the 8th times 4.7 times 10 to the negative 7th. There's a few mistakes people make. First, we're going to take our tens and we're going to put them together because we have the same base with exponents, and so hey, we can use those rules we were just talking about, and now all we have to do is figure out 3.28 times 10, no, not 10, times 4.7. And so it turns out that that's 15.416 times, now I just have to figure out what to do with those exponents. Well, I have the same base being multiplied, I add the exponents. So it's going to be times 10 to the first. And a lot of people will say that's the answer. Think about it. What's wrong with that? Why is that not the answer? That's not the answer because we need this number to be between 1 and 10. So that's an equivalent expression, but it's not scientific notation yet. So to get that into scientific notation, I know it's going to end up being 1.5416, and then we have to figure out which way is the decimal moving. Well, I have 15, and I'm making it smaller, so my exponent has to get bigger, right? And you could, if push came to shove, you could always try it both ways and see if it worked. Well, we know it can't be 0. That definitely wouldn't work. And so it's got to be getting bigger. It's got to be 2. So because if I have 1.5 times 100, that's going to be the same as 15 times 10, right? And the same rules will apply when you're dividing. I'm not going to do an example. I want this to be a very short video. So remember, it's used to express very, very big numbers, very, very small numbers, and that number before the 10 to the some power needs to be between 1 and 10. And that holds true in the beginning, and if you do any kind of math and you're writing your answer in scientific notation, it has to be true in the end as well.